And the time spent watching TV per week by students is a normal distribution with mean 20.5 and standard deviation 5.5. I'm going to find the percentage of students who watch less than 25 hours per week. So in this case, we are having our variable is time spent watching TV. So we'll be having that will be our variable x. So in this case, we are looking at x less than 25 hours. So we have to find the probability that x is less than 25. Then after finding that probability, to get the percentage, we multiply that by 100. I'll start by looking at the first method using the probability distribution tool. I'll go to my command window and type dist2 on the distribution tool, then click on the return key, and we have the distribution tool coming up here on the screen. So this is the probability distribution function tool, and we enter our parameters that we have here. So I'll go on and enter my mean there. The mu saying is 20.5. And then I click on the return key, and then enter our standard deviation. So it will be the sigma. So this one here is 5.5. Then click on the return key. Now for the probability of x less than 25, we type in our x here to be 25. Then click on the return key, and our probability is displayed here, 0.79334. So to get the percentage, we multiply this value by 100, and we get 79.337. So here you should be noting that we were using the cumulative distribution function, and I had selected here the normal distribution just because we are saying it's normally distributed. Click on the drop down, then check on the cumulative distribution function. For the probability density function, we'll be looking at the probability that x is equals to a certain number, not the cumulative as in this case. So that's our solution there. I will just close this one and then go on and use the second method of typing in this using a command. So the probability that we'll be wanting there, I'll call it P, is equals to, we use a norm CDF, normal cumulative distribution function, just like what the distribution tool was using, but interactively. So we put on the parentheses there, and then we put our x, and the one that we want is 25, then comma, we are now putting on the mu, which is the mean, so it's 20.5, and then comma, and then we go on and put the sigma with the standard deviation, so it's 5.5. So this is how we get the probability then we go on and run. So we get the probability is 0.7934. Then for the percentage, I'll call it percent is equals to, we multiply the p by 100, so it will be p multiplied by 100. So p by 100, and go on and run, where we have the percentage there is 79.3373. So that's our percentage there. Now I'll go on and look at the third method of finding that percentage using a statistical table. For us to use the statistical table, we say that we are finding the probability that x is less than 25. So what we have to do before we go on and consult our statistical table, we have to standardize the random variable, the x. So we standardize by setting z is equals to x minus the mean divided by the standard deviation. So when you standardize, we get z is equals to 25 minus 20.5 divided by 5.5, which will give us 0.818. So that's the value that we have there for set. So we need the probability that set is less than 0.818. And then we go on to our statistical table. So the table looks like this one here. So we have the standard normal distribution. So it's saying standard normal, we are looking at the set score. So of the set score here, what it is saying. So we need 0.818. So here we look for the set. So we look for 0.8. We go on, 0.8 is here. Then it's 818, but on our columns here, we just have 2 decimal places there. So when you look at the columns there, we cannot have this 8. So we can just let's round this to 0.82. So when you are looking at 0.82, we come to 0.8, then look under the column of 0.2. So this one is the one that corresponds to 0.82, and it's 0.79389. And then for our percentage, we multiply this by 100 and we get 79.39%. So that will be our solution when you are looking at the statistical table. Thank you.